Welcome. We're looking at 2.5, b there, b square. It's about modeling perfect squares. This will be the first of two videos. This video will be all about the modeling that you'll do, area models, as well as some of the graphing that you do. And then the next one will be the pure algebra part. So in this case, there's an order that was x minus 3 squared plus 4. And we're trying to figure out, if we were to graph that, what would it look like? So originally, you have the blue, which is just the x squared. Okay, and that is your blue parabola, your parent function. But the one we have is it's actually x minus 3 squared as opposed to x squared. When you subtract 3, that means that it happens later because you're taking away 3 each time. So in this case, I like to write this down here, that the parabola happens later because you're taking away 3. There's also a plus 4, and that means that you have a translation of 4. So it goes up, every point goes up 4, and over here it's occurring later. Okay, so this purple represents what that would look like if it's 3 later, up 4. Here's another one, x squared plus 6x, or x squared minus 6x plus 9. If you think about the side length as being x for this square, and then the height being x for this square, and you were to take away 3 from this side, and you were to take away 3 from the height, what you could see is we have x squared. We've subtracted 1, 2, 3. So we subtracted 3x. And then over here we've subtracted another 3x. And then the problem is let's see if I can get this to show up for us here. The problem is that right here we have subtracted it twice. First time on minus 3x also took this away. The next time also took this away. So in order to make this true, we have to add back the 9 that we subtracted twice. Okay, and then the question is, can you write this in a different way? And by the way, this is x squared minus 6x plus 9. And you can always use base times height. Area is base times height. Well, the base is going to be x minus 3, and the height is going to be, and actually let me fix that because we're only talking about to right here, and then the height of the green is also x minus 3. Okay, so you've got x minus 3 times x minus 3, because that's the dimensions of the green box. So the other way we can write it is x minus 3 times x minus 3. You're representing the area. That's also equal to x minus 3 squared. Now the vertex of the new parabola, so the blue is our original, which is x squared. But what happens with x minus 3 is it happens later. In fact, everything happens 3 later. So the new vertex, which is right here, the vertex will be at 3, 0. That's the minimum value. And it happens 3 later. Okay, and that's because you're subtracting 3. It's a little counterintuitive. Then they give you another one, x squared plus 4x plus 2. So on this one, you start out with x squared, and then you're adding 4x, so 1, 2, 3, 4, and then you're adding 2. But the problem is you're still missing 2 here, right? So it doesn't quite work, all right? So really, if we did have those two, it would be, let me write it here. If it was a complete square, you would have x squared plus 4x plus 4, because you would add another 2 here to make this thing a square. Okay, but really, because we added 2, then we need to make sure we also subtract 2. Another way to think of this is base times height. Base times height. And the base is x plus 2. And the height is x plus 2. So x plus 2 is the base, x plus 2 is the height. So another way to express this would be x plus 2 times x plus 2, or x plus 2 squared. Okay, and in this case, we have to remember that that's too large. So we would have to subtract 2 here. Okay. Is it equivalent? An adjustment's been made? Yeah. Since we added 2 to make it a square, we need to subtract 2 from the expression. And that's because, let's say you can't go from x to x plus 2 because x is not equal to x plus 2, so you need to go ahead and subtract 2. And then the last one for this video is identify the vertex and graph. So you can see the blue is where we started, x squared, but because we did x plus 2 squared, right? That's what we had right here, x plus 2 squared minus 2. So the x plus, since we're adding 2, that means it happens sooner. It gets big faster. So sooner means that it occurs sooner on the x-axis. Now the subtract 2 would be the final step. I'll do it in green. And if we subtract 2, we're translating every point so that it subtracts 2 from there. So you end up with this green parabola. And so the vertex, which is right there, is at -2, -2.